Ciao mondo, hello world, hola mundo, hello mon. We're here today with our cappuccino with Claudio Ronco in the occasion of the 40th anniversary Vicenza course on AKI and CRRT together with Professor Giuseppe Castellano from the Nephrology and Dialysis and Renal Transplant Unit at the Department of Clinical Science, Community Health at the University of Milan. And we are pleased to have Professor Castellano to discuss with us one of the important themes of today, which is how to prevent progression of AKI towards chronic kidney disease, in particular, this process of probably maladaptive repair that induce changes that are irreversible in the kidney. So, Professor Castellano, what are the elements of these aspects and what is the potential role of a specific dialysis membrane?
Hi, Professor Ronco, and thank you very much for inviting us. We know that the acute kidney injury is linked to the activation of innate immunity. And between the immune system, especially with innate immunity, the complement is playing a pivotal role. And in our recently published paper, we show that the complement system is involved in AKI to CKD transition. And the complement can be really detrimental in its activation on different renal cells, like on tubular epithelial cells, endothelial cells, and pericytes. And some mechanisms of maladaptive repair are characterized by the complement involvement, like the endothelial to mesenchymal transition, the pericyte to myofibril transition, and our last paper showed the senescence of tubular epithelial cells. So if we are late in counteracting the complement system, maybe we will not succeed in protecting the kidney and to block the AKI to CKD transition. And we recently showed in a model of LPS-induced acute kidney injury was that LPS is capable to activate complement, not only at renal level, but also at peripheral level. Because we show that at renal level, we found the activation of the classical pathway and of the alternative pathway triggered by LPS, with the position of pentraxin 3 and C5b29. So when we use polymethyl methacrylate CRRT approach, we found that adsorptive treatment could remove efficiently the complement component, like PTX3 deposit were inhibited, C5b29 were inhibited and removed efficiently compared to the polysulfone membrane treatment. And this was found also not only at renal level, but at systemic level, since we found a complete inhibition of the classical pathway and of the alternate pathway of complement activation. Finally, we found that polymethyl methacrylate could also inhibit leukocyte activation, because LPS could induce activation leukocyte with production of complement components. We found production, for example, factor D, that is activator of complement by leukocyte. So when we use polymethyl methacrylate adsorptive treatment, we could hamper the production of complement component by leukocytes. So we think that this new strategy could modulate the innate immunity upon activation of LPS, and maybe a future therapeutic approach in these very critical patients.
So this is a very interesting approach. In practical, we can say less generation of complement and absorption of the fragments of complements or fractions that are present. I think it's an excellent, interesting approach, and more together with diffusion and convection, adsorption is becoming a very interesting mechanism, especially for directly sorbents or for membranes that have adsorbing capabilities. With this, I thank you very much all for following our cappuccino today on how to try to prevent AKI to CKD transition, and have a wonderful day.
Excellent.
Excellent cappuccino.
Excellent. Thank you very much, Professor Ron.
Thank you. Thank you.